I have a second channel, Cube Comp MTDX. Hey everybody, here we have this massive Dell laptop battery. It came from, I think a Dell is from 5100 laptop. It's one of the big fat Pentium 4 laptops from like 2004, I think, 2003, 2004, that time period. This is a factory original battery pack, I do think. It's a model number BATDW00L. 14.8 volt, 6450 milliamp hour. This is a 12 cell battery. It is a 4 series 3 parallel battery pack. Made in Japan. So, out of curiosity and just for fun, I'm going to crack this thing open. See what we have inside of it. Now, this battery pack is built like a tank. I harvested Panasonic cells from one of these years ago. It was actually an 8 cell. It had 4 of these dummy cells in it. They were just this little plastic tubes that took place of an actual cell. But this one is the real deal. It has all 12 cells in it. So, you peel this label back. You can already tell what kind of cells we have in here. Of course, it says made in Japan. And also, when you peel this off, that bright green is a dead giveaway. These are Sony lithium-ion cells. Looks like we have 2 temperature sensors here. These are either temperature sensors or they're thermal fuses. They look a lot like the thermal fuses that you would see in a hairdryer. It's kind of interesting. So these, I'm trying to remember how I exactly got into these things years ago. Back in 2016 when I last dealt with one of these. And this is a pretty hard case, I must say. I thought about using the case to store cells in on my table. Because I'll be honest with you guys, I'm not really expecting too much out of these cells. Because this is an older pack. But I figured just for the heck of it, I'd open her up and see what we have. So, in this pack, I can tell right here, you can see, I gotta do a better job paying attention to my camera LCD. So, negative, positive, is a power goes this way. Just see positives here, negative here, positive and positive. So anytime you're cracking into these battery packs, you always want to try to stay on a. You always want to. It's the best way I can word it. You don't want to be poking around the positive side of a battery. And what's interesting on this one is I'm seeing a red wire coming around. I know what it's for. It's probably it's a balance wire. And I was like, what the heck's going on here? So also gotta be careful not to damage these balancing wires. I tell you, these these hard cases can be a pain to get into. And I think if we can get these snaps loose on the corners, we'll probably be in pretty easy on this one. So I have no idea these things are even holding a decent voltage. Okay, so man, I thought I cut my thumb open there for a second. It's just the pressure of the plastic on my thumb. It made it feel weird. Definitely gonna need to get the famous needle nose pliers for this one. Probably the oh, they're already in here. And probably good pair of dikes. And I don't know where my Craftsman ones are at. They're probably in the kitchen somewhere, but I guess we'll settle for these if needed. Yeah, so we have a balancing wire that comes around here. And it's funny, as I figured, I would get a comment saying you take a long time to crack these things open. Well, that's just me. I do. You know, for those who process a lot of packs for like power walls and things like that, I can definitely see why you would want to go at a faster pace. But me, I take it slow. I take it slow, just try to be careful and to be safe. Because I'm not mass processing these things like others are. Yeah, it's interesting. You know, I'm getting further into this. These balancing wires, which could be actually no, excuse me. This is really interesting. It looks like this red wire here is actually the main 14.8 volt wire. From the positive up here, it runs. Looks like it runs through here and goes through these thermal fuses. Those are thermal fuses, I think. So if the entire pack gets too hot, it cuts out. Or if the fuse pops, and that's the end of it. It's a rather interesting design. I've never seen thermal fuses in a laptop battery before. I've always seen thermistors that go back to the main control board. That's about it. Okay, so over here, gotta be a bit more careful because we have positive terminals over here on this side of the battery pack. Yep, these are Sony, I think Sony Fukushima US18650GRs. The last time I harvested these, the last time I harvested these type of Sony cells, I had an issue with them getting too hot when charging. Those could have been bad cells, and I'm not sure if these are even the same kind. These very well could be a whole different type of cell. This is a massive freaking battery. Yeah, if these cells are good, it'd be very surprising if they are. But if they're good, that would net be a bunch of cells. I think these are probably from the total being 6450. It could be 2150 milliamp hours, or perhaps maybe 2200. Okay, yeah, this red wire is definitely the main wire for the whole pack. Because I see a much skinnier balancing wire coming through here. Perhaps it could be an extra means of safety that the manufacturer put into this battery. It's not a bad idea in my opinion. I think it is a good, you know, if all else fails approach to preventing the pack from, you know, exploding. Yeah, I got some files copying off of the computer. I'm getting ready to reinstall Windows on. So I'm harvesting this battery during the downtime. Okay. Let's see, I think we're making faster progress on this battery than I did on the previous one of this style that I did back in 2016. Okay, so we want to leave, we definitely try to leave these cells intact until I'm ready to pull the whole bunch out, because I'm looking at how they're stuck together, how they're spot welded together rather. So it looks like it starts from here. There's a big piece of metal spot welding these together. And there's a big long piece of metal here. And then there and there. I tell you guys, this battery holds a serious amount of capacity. Or at least it did. Excuse me. A little bit of a dry cough once in a while. So it looks like this thing might pop open the way I'd like for it to pop open. Yeah, because this top cover I don't care about, but this bottom portion I think would probably make a nice cell tray, especially if I can preserve the plastic dividers that are in here. It's pretty funny when someone cracks open a laptop battery, probably in more interest of the casing than the battery cells themselves. Well, if the cells are good, that'd be great, but again, this is an older pack, so I'm not real sure. Okay, so one thing, if this is your first time ever witnessing a laptop battery harvest, well, you get past this point here. You see I got these metal pliers. Well, right here you have metal contacts, and if you're not careful, you can ground something out and short something out. So you always gotta be careful when working around these things. But wow, this pack is I'm surprised. I really am. I was expecting this to be a real pain in the butt to get open, but it's seeming to me kind of the opposite of that. I guess some of them just open easier than others. Okay. We are almost in. Get this little piece of plastic here out. That's it. We are in. So 12 Sony lithium-ion cells in this big pack. And again, look at this. Here's the positive coming off the circuit board. It runs through here, comes around here, goes through here, and goes through not one but two thermal fuses. They're rated for, yeah, it's funny, these are the same kind of like thermal fuses you'll find in a hairdryer. Now their voltage rating is 250 volts. Yeah, these are regular wall voltage thermal fuses. I'm trying to see what the temperature rating of them is. They're kind of hard to read. I think these are thermal fuses. These might, given how there's two of them in series, would tell me these are likely thermal fuses. That is interesting, I'll be honest. Okay, so now that we got the pack open, it's time to go ahead and measure our voltages and see how this battery pack is actually doing. So this came in an older laptop. For all I know, may have been sitting in storage for quite some time. So let's have a look at the pack voltage. The pack voltage is, well, if my meter would cooperate, that'd be nice. I do have the leads backwards too. We have 11.3 volts on the entire pack for a 14.4 volt. For a 14.8 volt pack, that's not bad. Now, let's see what the individual cell voltages are, or at least of the groups. 2.7, those are a little bit low, but could be recovered. These are at 3.1. .94 and 2.5. So they're all sitting at the voltages are pretty low on all of them, but they're all within the range of what I would attempt to recover. Now I will say it is pretty common for laptop batteries, especially older ones like this, when they've been sitting for a while. You can't rule out the things getting low voltage on them over time. Okay, so now I'm going to begin to dismantle this pack. So I think I'm going to start by disconnecting right here with these thermal fuses. So that's a thick wire too. Very thick wire. It's a rather interesting thing to see. There's our entire circuit board. Here's our balancing wires. do like how well this pack is laid out. I mean, everything is pretty neat. So here on this side we have the thermistors that this circuit board uses to monitor the temperature of the battery pack. Okay, so our circuit board is now isolated from the pack. Let's have a closer look at those thermal fuses. Again, I believe that's what these are. These are probably thermal fuses. Let me see here. Yep, micro temp. 250 volts. These are rated to blow at 98 degrees Celsius. Yeah. So these are essentially a last resort safety device on this battery pack. Okay, unfortunately I ended up losing some of the footage because the battery died in the camera. And what's funny is my Sony camera, when the battery gets low, it just stops recording and shows a brief battery depleted message, but does not shut the device off. It just keeps the device stays on. So a quick glance at the LCD, I think I'm still recording, and turns out I'm not. But anyways, got the groups of cells out of the pack. It wasn't much to it. Just had to lift up a little bit on each of the three to pop them loose from this glue here. So I got myself a really nice holder for 18650s. Now this is really just to set on my table, and I set the cells inside this, and it stops them from rolling around and things like that. Kind of like what I already have on hand. And if you didn't see the footage or see me showing off these thermal fuses, that's exactly what they are. They're thermal fuses. They're rated at up to 250 volts. So these are like what you would find in almost like in a hair dryer. Micro temp is the manufacturer. These are rated to trip or to blow at 99 degrees Celsius, it appears. I see a 099C on the bottom. Yeah. This is the first time I've seen this kind of protection in a laptop battery. Yeah, this circuit board does have thermistors. It has two of them. And they were actually resting on the other two groups of cells, while these thermal fuses were on the first two groups. It's interesting. It is definitely an interesting protection device, but not a bad idea. So I did confirm the voltage of all these four, and they are sitting between 2.5 to about 3.1 volts, depending on which group of three we're dealing with here. So I will say that it is possible that these could be recovered and used, but there's three things. Number one, when you go to charge them, will they get hot? The last time I harvested Sony lithium-ion cells out of a different Dell laptop battery, that's a problem I had with them. They would just randomly turn into heaters when you went to charge them. It was kind of like those cells I harvested out at generic HP replacement laptop battery recently. And they were getting really hot when charging. This is at a random. Number 2 is the available capacity that they'll hold. I gotta look up and see what exactly the capacity of these are. These are Sony Fukushima. They have the SF on them. US18650GR. T space G5119 LJ03K. These are 2200 milliamp hour cells. They have their standard charge is about 1.3 amps. Minimum voltage of 2.75 volts. Nominal 3.7 volts, 4.2 volt max. Now just to figure out when they were made. Don't you just love websites that like to jump around as they load? Yeah, can't stand it. Okay, so L J 03. Yeah, these are old. These are rather old cells, guys. These were manufactured on Friday, October 3rd, 2003. Wow. So these cells are about 16 years old. Yeah. So there's a good chance that these cells may not be up to par as far as their performance goes. And that brings up number 3. Is the self-discharge. What will they, when you go to charge them up fully, what will happen when they sit? Will they lose? How much voltage will they lose? That's the other thing. So yeah, when I harvested this pack, I was not expecting these cells to be all that great. I might be surprised. They actually might not be too bad, given that they're all sitting at a recoverable voltage. Usually when they get below 2.5 volts, you start to really lose capacity on them. But we do have a nice holding tray. So, to wrap this up, it's time to go ahead and begin removing the tabs off of these things. Okay guys, I just finished peeling all the metal pieces off of these things, and I got them in groups of 3. I'm actually going to put them in groups of 4 later on, but just for now, this is how they are. 12 cells, ready for 2200 milliamp hours each a piece. I'm pretty certain they're not going to do that given their age. I mean, they're 16 years old, for crying out loud. These are probably the oldest cells I've ever harvested. Probably second would be the Panasonics from a similar laptop battery from the same time period. But those batteries were sitting at lower voltages. They were like at 1.5, 1.6, 1.8 volts, something like that. And I harvested them and charged them back up, and while they didn't get hot, they didn't seem to lose charge while sitting. The capacity just really wasn't all that great. So we'll see how these do. We'll see how these charge, if they get hot. Hopefully they don't. See if the capacity is good, and then see if they lose a charge while sitting. It's good to know that all 12 of these things, there wasn't a huge variation in voltage. It was like between what, 2.5 to 3.1. Now these things have been sitting for quite some time, I'm pretty sure, and I'm pretty certain they were probably sitting in a discharge state. With these things sitting at like 2.5 volts, or at least one of the groups of three were like 2.5 volts, the circuitry would probably lock out and not even try to charge them. So we'll just have to see. We'll just have to test them out and see how they do. Not expecting anything too spectacular, but who knows, they might actually perk up and work fine. And I got this really nice holder to hold them in. Can't beat that. So I'm going to number these 1 through 12 just for testing purposes, and that way I can identify which one is which. And I'll probably be following up with a different video on testing these things out, and that's going to be quite. It's going to take some time to test these out because we got 12 of these things. And of course, my Opus charger, I only have one of them, and it's a 4-bay charger, which is better than what I've seen some people doing. For example, buying the RC charger, I forget, the LiPro balance charger, and using it to test one cell at a time. Yeah, that's time consuming. I'd rather not waste time. I'd rather have something like that up there that can do 4 at a time. But anyways, that was a fun little big harvest. Hope you guys enjoyed the video. Thanks for watching. Well guys, that's it for this one. But it doesn't have to be. There's plenty more videos on the channel to check out. Also, if you liked the video, please click the like button. And if you absolutely hated it, there is the alternative button as well. But yeah, please subscribe to the channel. I definitely appreciate it. And remember to click the bell so that we get notified of all updates. Also, if you're interested in things aside from computers and technology, check out my second channel. It's CubeComp MTDX. Over there you'll find videos about weather, elevators, bicycling, and pretty much whatever else I figure out to upload. So yeah, anyways, hope you guys enjoyed this video, and thank you for your support.